Hey, great to have you all with us in the session. So, yeah, Phil, I think we are live and are ready to go. Hello, everyone, and welcome. Today, we are diving into Power Hybrid Search plus chat in your application. In this session, we'll show you how to modernize an application search capabilities. So our application has the first iteration of the application has a basic filters and tags. And then over the course of this session, we will enhance the search capabilities until we have really an AI-powered discovery. So we are going to use Astra DB's data API. We'll unlock semantic search and we fuse it with keyword search. And actually, for the ones who wonder what is hybrid search is the combination of both, a combination of semantic search and keyword search working hand in hand. And we even go further and provide you with information how to implement a chatbot, a product recommendation chatbot that is powered by Langflow to have a conversation with a product catalog. So this workshop here, so this session here is a hands-on session. So it is a hands-on code walkthrough. It is minimal slides, so I expect only a few slides to introduce into the topic, and then it is maximum doing. So get ready to get the hands dirty. So the first thing we are going to do is we would like to introduce to you the team here in this session. And Phil, please introduce yourself.
Yeah, hello, thanks, Dieter. So my name is Phil Measley. I am an AI architect at DataStax here, based in Ireland. My job here is to kind of help customers to design and uptake AI-based applications, based largely on Langflow and our database technologies, Astra and HCD. Thanks, Dieter.
Thank you. So I'm Dieter. I'm a solution engineer. I'm based in Germany. And yeah, I work with many customers like Phil. And these days, it's all about AI. So we help customers implementing their AI use cases and help them to bring the use cases into production. On this slide, you can see our LinkedIn handles and also barcode. So if you like, please connect with us. And Phil and myself, we worked on the content over the last 2-3 weeks, beside the typical work we do each day, right? And we would be super interested in your feedback. We would like to know if this is usable. So yeah, please connect if you want. That would be great. So with this, let's have a session overview. So it is a learning session. So you will learn about technology, about Astra DB, the data API, about services that we have within the platform. But most important, so this is a modernization, learning for modernizing the search capabilities of real world applications. So it is hands-on. We want to walk you through the code, explain the code, execute the code so that you see what all the code is actually doing, what all our demos are doing. And yeah, so we leverage technology as said. And here on this slide, you can see $vectorize and $hybrid. So these are operators available with Astra DB. And hey, don't worry, we will explain everything in detail, and you will see how simple it is to use all that to get a smarter search at the end. And we even introduce you to Langflow. So Langflow is an open source project. It is a low-code platform to implement any kind of generative AI use case. And with this, we show you how you can implement a chatbot for a product recommendation service to have a conversation with a product catalog. So with this, Phil, so I believe it is time to give the attendees a teaser so that you folks really understand what we are going to deliver in this session.
Yeah. Okay, so what we have is built is this company called Kinetic Constructs. And I've built that in Cursor with largely the Gemini 2.5 model. I did it a few weeks ago in terms of the starting point, but the code in this is AI generated. The content is AI generated, including the pictures, which are DALL-E 3. And I am not a full stack front-end developer, but it's a plausible enough looking application. And so what we'll do is that we're going to start with basic category and keyword like tag filtering, and then we're going to add Langflow Chatbot onto that. So Dieter, if I could share my screen here.
Absolutely.
I'll just give you a quick little
Now you
idea
should
here.
be able to share the screen.
Yep. Screen here, this screen here. Off we go. Voila. You should be able to see kinetic constructs. So this is the application that we have here, and it's the idea of this is we have Explorer kits, or the search products is the same. Here we go. The idea is this is a product catalog that might be part of an e-commerce website kind of application. And we have a fairly traditional way of navigating the products. We can go by product category, or we can search by tag. So for example, if we wanted to use playsets, right, we can search for playsets here like this. This is using Astra DB in the background. We're not using Elasticsearch, but you might have Elasticsearch or whatever. And where we're going to end up with is something like this. I am looking for a playset for a 12-year-old with lots of typos. And so the chatbot is going to basically go and do a hybrid search in the background. It's going to look, it's going to break my query apart into semantic keyword search and a semantic search and a keyword search as part of the hybrid search. And it's going to basically be responding here to me. And this is running in code spaces, so things are a little bit slow at times. I haven't been able to work out the rhyme or reason as to what's happening with that. But it's going to end up giving us a response here back. And so here we go. Some exciting play sets for a 12-year-old. And so this is the idea of this. And then it's going to draw here a little product card. And like obviously in a production application, you might do this in a slightly different way, but it's all we go. And then as these cards are going, we can actually like click on them. You may need to wait for that to render all the way as a page. But that's the idea of this. So we're going to work our way up to that. Dieter, I'm going to throw it back to you, and then we can kind of dive into some of the code and how that works.
Mm-hmm. Okay, perfect. So yeah, let me share my screen again. So yeah, so with this, so this is actually really all slides we have today. Now it is time to stop talking and to really do some code walkthrough and explain and run different iterations of this application so that you understand how we got from really these basic search capabilities and how we extended it until we get a conversation with our product catalog. So with this, let me show you the GitHub repository. So everything we show today is available on GitHub, and the link is provided to you to that repository for the fast ones here within that session. So you could really follow along. So what we do here, you could follow along in real time if you want, but if you prefer to just listen, that is also fine. We are going to explain every little step that we do here, and you can do the recap and do all the exercises after the session, whatever you prefer. Okay, so this is the kinetic constructs repository. Everything is documented in here, and actually, so what are we really solving with this? So many of the applications around, they have basic search capabilities. Quite often it is a keyword-based search. And so this is our starting point. So this is what Phil already showed to us. And then what we are going to do is we extend the search capabilities. So the first iteration that we show you, so it is about adding semantic search to the application. So this allows to really specify within a sentence what we are looking for. And then we search over the whole product catalog to retrieve the most relevant products out of all the products that we have. The next iteration is hybrid search. So with this, you will understand what hybrid search actually is. As mentioned before, it is the combination of semantic search with keyword search. And we will dive into the details so you will understand how it works. We have an advanced version of the hybrid search that we want to educate you about. And then the last iteration of the application contains the chatbot that is powered by Langflow. So Langflow, there is a vibrant community behind that, more than 60,000 stars on GitHub. So this is really a low-code environment that everyone would like to use. You will see how you can implement any kind of generative AI use case in no time. So we already saw the application, the kinetic constructs. Yeah, it's a fictional application, as Phil already explained. It is about a number of toy products and different capabilities for different ages. They fall into different categories. And so we can search over all that. So that is the point. And we would like to provide this application or integrate a search that really retrieves what we are looking for. And you will see with each of the iteration how actually the results improve. So in order to follow along with this workshop content, so what do you need? It is a GitHub account. You need a DataStax Astra DB account. Astra DB is Cassandra in the cloud, and you get an account for free. Then OpenAI, an account. And the reason why we need an OpenAI account here for that content is we leverage their services. We leverage the embedding models they have to generate the vectors that we use for the semantic search. So first, and I will not go into too many details, just to explain what you need to do. And we will soon get to the application iterations and talk a bit about the code. So first, you need to sign up for Astra DB. So you will see that's super easy. It takes a few seconds. And once you have an account, then you create a database within the UI and choose the serverless vector database. Very important is you need to choose AWS as provider and also the region US East 2. The reason for that is, so we use some capabilities. So they are leading edge, they're brand new, and they are in preview right now. So they are available in this region right now only, but will be soon available in any other region. So once you have the database, so it will take 1 or 2 minutes until the database is provisioned for you. Then you will find on the right-hand side within the UI the credentials. So we already mentioned the data API that we are going to use. And this data API needs two things. It needs an API endpoint. So you copy it here, and it needs a token, application token. And baked into the token are actually the roles, access rights, but just use the default for that. And once you have all that, store it in a safe place locally on your machine, and we will need it later. So then sign up for OpenAI. As said, we use the embedding models they have and create an API key. So we need that credential for our applications. Once you have that, so what we leverage within the Astra platform is a service that is called vectorize. And this makes it even more simple for developers to vectorize their context. So typically, a developer does the vectorization of context within the application with application code. We free you from that. So the only thing that you need to use is actually a so-called operator. And there is the $vectorize operator. As soon such an operator, you have such a field within your JSON-based data, then and you pass that to Astra DB. Astra DB knows, okay, I need to use the vectorize service and reaches out to the OpenAI integration that we have for vectorize to vectorize the context that you provide with $vectorize. You will see it when we talk about the code, right? And with this, we get the vector, and this simplifies things for developers quite a lot. And you need to follow these instructions. And so what we also need is within Astra DB, for this feature, we create an API key. And this API key is also something that we provide later to the application in a so-called .env file. Okay, and you also need to specify for which database you would like to use that vectorized service. So that is mainly the prerequisites in order to get all the credentials required to execute all these application iterations that we have prepared for you. And so the next thing is then, so you do not need to install anything locally. So what we use here for this content is GitHub code spaces. Before we get to code spaces, yeah, it would be really good. Take a fork of Phil's repository. So that is the link, but the link is also provided within that webinar environment. Do a fork, ensure that you copy all the branches. So this repository comes with 2 branches, and we would like to have in the fork all these branches. Actually, this session content is within the workshop branch. So once we have the fork, the next thing we need to do is switch to the workshop branch within your fork. And then we are ready to rumble. We are ready to execute something. And the first thing is we create a code space environment within GitHub. A code space environment is an environment where we can execute our code. So there is no need for you to install anything locally. And once you have created the code space environment, you get something that looks like what I have here in front of me. So that is my code space environment. On the left-hand side, we have our clone of the repository. So all the source code files, but also important to note, so there is a .env example file, and you already find a .env file. And in the .env file, so this is where all these credentials need to go. So the Astra DB API endpoint, the token, then the integration API key, and also the OpenAI API key. So you need to configure it in the .env file. And so leave all the other configurations like they are. And that's all you need to do. Then, once we have the code spaces environment up and running, once we have configured all these credentials, we are ready to load data into Astra DB. So this is data about the products. It is, I will show you how it looks like. So that is the best. So with these 2 Python scripts, you load the data into Astra DB, and the credentials we have provided before. So all that is used in order to ingest the data into the database. And what you will get is what you see here. So I have here my kinetic constructs database. So that is the Astra DB UI. It is Cassandra in the cloud. And so what we have here is so-called collections. And in these collections, we manage JSON-based data. And actually, the API that we use is quite compatible with the MongoDB API. So if you are a MongoDB user, it will be super simple for you to understand how everything works, how to ingest data, how to search data. So that is very easy. And so I already ingested the data. All these boxes contain so-called documents. And in the documents, we have a number of fields, as you can see. So it is about the toys. The toy has a name, so there is a playset, then there is a description, and it falls into a certain family. the toy has a price and has tags, and there is some other information. And actually, what we leverage during the ingestion of all the data is the so-called vectorize service that I've already explained. So see the $vectorize field that we have within our document. So this is the key and the value of that key. So it is quite some contextual and text-based information, right? So there is quite some context, quite some meaning within the text. And so AstraDB sees $vectorize once we pass the data to the database and then reaches out to OpenAI in order to generate the vector for all that context to capture the semantic. And the vector is what you see here. So this is how it works. And this vector is what we leverage when we do a semantic search. So we will explain a bit more about that when we are at the stage of executing application. So, so once the data is loaded, and when you load the data, it will look like this for each of the scripts. So there is a bit of output that you will see, right? And then we are at that point, we are ready to execute one of these prepared applications. And as said before, we implemented a number of iterations to show you the differences of the search capabilities and the relevance. Actually, it retrieves out of the context that we have. And with this, Phil, I would like to pass the ball to you so that you can go into a bit more details about server JS and the first application here. So we are
this way,
muted.
and now I share my screen here, and we'll get there. We'll get there in the end. Okay, excellent. So continuing along here with server.js. So this is a Node server. In fact, it's in Express, but it's largely Node kind of based things. And so what we have here is the main code in this search route in server.js that allows you to basically say, look, if I'm looking for a create a Spark family, then what we do is in our query, in our find criteria is family create a Spark, or we can specify tags in a list. I need to have all of these tags. And we can combine those together with $. And so again, if you're familiar with Mongo, this would all be very similar and consistent with kind of what you've seen there before. And this is the basic function that we're about to modify and enhance to add in these new advanced search capabilities and just show you how easy that is. Ultimately, what happens here is this up above is kind of building up that filter as we showed up here. And here's where we do a product. That's the way that works, isn't it? Product collection.find, and the options are the search options that kind of we had there. So that looks very much like a Mongo place, and we basically hand that back out to the products, and then that gets rendered into the UI. So that's the server JS approach. Now, the trick on that is that if we're looking at this here, right, in our search products, so we're now confining ourselves. So our users ignore the chatbot. We're not using that. This is before the chatbot. Our users have to either say, oh, I know how you've organized your hierarchy, and I'm going to navigate things by the hierarchy, or they're going to search by tag, in which case they're somewhat beholden to your tag extraction technique if it's automated or manual. But for example, if I was looking for robots, right? Okay, great. I've got 25 robots here. Awesome. And now here's all the robots. I actually want to have robots with legs. And if I were to go and count here, I'd find that we in fact have 7 robots with legs. Now I'm going to search for my leg here. I see, oh, we've got legged here. Now I only have 5 here that have a tag legged. And I'm looking for legs, not legged, but I guess I would have learned as a user, oh, I guess that's what I'm going to do here. So there are some limitations here in terms of, one, the user has to have some basic understanding as a user interface. And two, they kind of need to search in the way that you've told them to search, by category, or here's the tags that you have. So we can do better than that. So Dieter, I'm going to hand it back to you, and you tell us how to make it better.
Perfect. Let me share my screen again. Okay, so that was server.js and the initial application. And so this application is on that stage as many applications around, applications that we use daily. And hey, it would be super nice to have the capabilities of a semantic search. And this is what we are going to add in server1.js. And therefore, we leverage $vectorize. So we have spoken about that before. So this is operator. And let's have a look at the code. So actually, there are mainly two lines that are important to have a look at here within that code snippet. So there is the sort options. So in the server.js example, it was empty. And this time we say, so we would like to have the results sorted based on the semantic search, on the vector similarity. And therefore, we need to pass the $vectorize operator with the semantic query. So actually the semantic query, you will see it in a second. So this is something that we provide in an input field. So there we describe what we are actually looking for. And so we pass that to the Astra DB platform by executing this line of code. And actually, so this line of code is 100% similar than what you have seen in server.js. The difference is just that options is now different, right? So we pass that via the find method to AstraDB. AstraDB sees, okay, so there is the operator $vectorize. So I need to vectorize the semantic query in order to get the vector. And with this, we do a vector search over all the products that we have within AstraDB. And as you saw before, so we have for all these products, for all these documents, a field that is called $vector. And so these are vectors. So there is a vector space. So all these products are within the vector space. And now we have a vector for our semantic query, right? And what the platform does, it calculates the distance between our semantic query and all the products that we have vectorized to find the most similar products to our query. And that is what we retrieve. And what we want to have is actually the most relevant products to our query. And now let's see that in action. So simply hit that icon here to copy the command that we need. And hey, before we do that, maybe a bit more about the code spaces environment, right? So this is completely prepared. There is no need to install anything. So all the required Node modules for our Node application and also for the Python scripts that we have used before, everything is pre-installed. And just for the ones who do not know the code spaces environment, so whenever we use a terminal and execute something in here, like this command, the node server 1.js that starts our application. So this is then executed within the container. So let's do that now. And as you can see, so the application reads right at the start the credentials that we have provided in the .env file. And with that, we can go and execute and do whatever we want to do within the application. So the thing I want to do is actually, I want to do a semantic search. I would like to search for the robot with legs. And let's do that. And as you can see, yeah, quite good. So we have a number of toy products. Only a few of them are actually robots with legs. And for your information, so all that is sorted. So the most relevant products are at the top, right? So the robots with legs. So we have 5 of them, but then we see some rover bots with wheels. And here again, so there is a robot with legs. And if we go a bit deeper, then we see, okay, so there is a robot with legs again. But actually, what we want to have is we would like to get all these robots with legs. And so let's get there by improving the search step by step. So that was the first application iteration, the one with semantic search. And the next one is iteration that leverages the hybrid search. And yeah, mainly the thing that is different is the operator. So now we use, instead of $vectorize, we use the $hybrid operator, right? There is some documentation, some explanation. We go directly to the code. And yeah, as before, so what we need to do is we need to specify the options for the sort property. And this time we use $hybrid. Then this is where the semantic query, so the robot with legs, goes in. And so what we execute actually here in this case is that line. So it is the findAndRerank method for the that we execute on the product collection. And as you can see, we pass in the options that contain the $hybrid operator to do the hybrid search. And as said before, I need to explain a bit more here. So hybrid search does actually two searches. So it is the combination of the semantic search. For the semantic search, the platform vectorizes the robot with legs into a vector, and then we search for the products and their vectors with the closest distance. But it also does, it extracts from that semantic query keywords that are used to do a keyword-based search. And so these two results that we get back go into a re-ranker that is part of the platform, and that ensures that the most relevant results are on the top of our search. And let us have a look if this already improves things with our search here. So we go back into the CodeSpace environment. We stop our server 1.js and execute server 2.js with the hybrid search. Same thing, same procedure as before. Open it in the browser, and then, yeah, I copy here the robot with legs semantic query in, and then let's do the search. And let's see if there is already an improvement. And hey, yeah, so if we compare things, there is an improvement. So in the top row of the last search, we had 5 robots with legs. And now we have one more here with legs. And so the last one of the 7 robots we have in our catalog actually is quite close, but there is something in between. So still not perfect, but compared to our first search, so it is an improvement. So let's continue things and improve our application and the search capabilities even more. And we do that with iteration 3 of server JS. And as before, you find explanations about the difference to the iteration 2 here. We go directly to the code snippet that we have here. And also here we have the sort options. And this time, so what we do is we still have the $hybrid operator, but this time we have a $vectorize and the $lexical operator. And this allows us to provide semantic query text and also provide some keywords. So the keywords are not extracted automatically from the semantic query as in the iteration before. So we provide that in addition. So, and to execute that, so what we actually execute is this line here. So on the product collection object, we execute the findAndRerank method, and we actually pass in exactly the same. It has exactly the same signature as what we have done in the iteration before. But okay, the hybrid search, the setup here is a bit different. So let's see that in action, if this improves anything. Let's go back to code spaces, stop our previous iteration of server.js. We start server3.js and open the applications UI in the browser. Let's explore things if there is any improvement. Let's copy again the robot with legs text, and here I'm able to type that in, the legs keyword. So that is all that we use in this example, and see if we get an improvement. And so this is what we want to have. So this is actually, so within our product catalog, we only have 7 robots with legs, and we get all of them on the top of our search. So that means, so now we are able to, or we were able to improve the relevancy of all the context that we retrieve out of Astra DB with the hybrid search in this case. Okay, so this is the application and the hybrid search, semantic search. And now we go even deeper, and Phil will explain to you what you can do in addition by leveraging Langflow and by using the power of Langflow to implement all the Gen AI pieces actually in a Langflow flow. But hey, Phil, I stop sharing my screen and you can take over.
Yeah, great. So we'll come to the point of Langflow. So there's a couple of things that have happened here, right? This is fantastic. We have an ability to kind of search by meaning of words and add in these additional keyword search elements. So that's fine. Although we're now requiring our users to become more and more expert. And furthermore, we're kind of requiring them to spell things in the right way, unless we do some sort of, post input pre-query, cleaning up of the data to correct spelling conditions and all that sort of a thing. So now we've required our users to become more and more expert. So an alternative would be a chatbot interface, which requires us to not make any modifications to our existing user interface, rather just an additional kind of overlay into the existing application. I can do something interesting. So with that, what we are using here is Langflow, which is an open source, low code kind of environment here. And when you start up your CodeSpaces container, you get these 2 flows. But before I do that, let me just give an example here of how flows work and the overall idea of the flows. So Langflow comes with a number of pre-built flows. The basic prompting is sounded one we'll do a very simple example of. And then there's vector store RAG, which should require, here's a database. We'll do a search against the database using a semantic search, the vectorize, for example, that we're using in here. And there's a simple agent. There are other RAG sorts of things in terms of vector store RAG, hybrid search RAG. But right now, we're going to just create a blank flow and give you an idea of how this works. So this is the canvas. And on the left, we have these different commands. So the first thing we need to understand is, well, what does the user want to tell us? And I guess we need to do some sort of output, right? Hey, here's our answer back. And we're going to use a model here, right? So we can look here in models, and we can pull any number of these models, for example. But because we have OpenAI configured in our example here, we'll pull in the OpenAI example. And for this, we can connect our input, and we can connect our output. And we can put system messages like, what are we supposed to do here? Talk like you're a pirate, that kind of a thing, or change the temperature. We won't worry about any of that. But this is the kind of basic minimum of a chat flow. And so in here we have a playground. And this playground is, hello, how can I assist you today? Oh, you tell me a story, right? And so we're going to get a nice little story here from the agent. And if it plays nicely, the code space I'm in here today is a little bit sketchy, so I'll probably do the rest of my demo on my local. Okay, it didn't stream it. That's fine. It took a while because it was giving me a big story about Alara, who's a girl who became an astronomer. All right, that's an amazing story. Enough of that. So this is the flow idea here. And again, this can become more and more and more complicated as you want to add more abilities. So first, what I'll show is the flow, the key of the flow that we're using here, where we again start with the chat input. But what we're doing first is we're taking that user's input from the chat, and we are sending it into an LLM, whose job is to take that query and turn it into a semantic part and a keyword part. So if we get spelling errors or things like that, the LLM here is going to kind of automatically fix those for us. And it's going to understand what are the keywords that we should be searching for, and what's the general kind of meaning, kind of semantic query that we should be searching for. These are now passed as parameters into the Astra DB component. And here's where we see the re-ranker, and we've selected our products collection. And then the output of that is turned into a string and returned back. So this is going to be a very, from a user perspective, an uninteresting flow, because it's sort of like some sort of chat input, and what you're getting out is like a dump of some tables, right? That's not particularly useful or helpful. So what we have here is the actual chat flow, where we are using that previous flow I just worked through here as a tool that we're giving to an agent. So now the user's real query goes into here. The agent takes that current user query, combines it with the previous context within the chat to form a query that it passes to the product catalog search. It gets all of those results back with the full documents and all of that, and it understands, here are of the documents I've gotten back, here are the ones that are most relevant to the query, and passes that on to the user. Although, if we look here on the covers in this prompt, this is a flow that we have aimed to send back to a chatbot. And in our application, we're asking it to give us specific, classes and our, sections, etc., because we're going to use that with listeners and other things on the HTML on the Node side of things to kind of modify things to make it look the way that we want to. So whereas the first flow, we put in a query and we got back a bunch of basically JSON document dumps, here we put in a query and we get back some HTML. But that HTML is quite useful. So we can use this in a playground again. And that was, I suppose, a previous chat here. So, and this is our, for a 12-year-old, right? Or our leg robots, right? We're actually robot with legs, right? That's what we were searching for here before. And so we can see here in the playground, which is just kind of helping you diagnose and understand what's going on, is what it's built to do. And it's calling the tool, and it's searched the tool, and it's gotten the results back, and now it's thinking, right? It's processing through the results it's gotten back from the tool and figuring out, here's what we're going to do. And if I look at this here, right, this is the query that it sent in. It didn't have any further context than what we had with that. And again, this code space is so slow. Okay. That's going to come back with our answer about the robot with legs, but we'll hold that on here as a surprise. I'll show it here. So that's the kind of the basics idea of Langflow. So we create a new terminal window. We run Langflow with our end file. But one thing to point out here, the way that this application is built is our end.example has this Langflow endpoint URL. So to enable the chatbot, you simply, in your real.end file, not the end example file, you'll comment that Langflow URL back in. and then you restart your server. And here we're just running, we're running server, any of these servers, server.js or 1, 2, or 3.js, all of them will work with this chatbot. It'll show up. Okay. So that said, that's Langflow here. I stopped that there partway through. We have this part here. Oh, I wanted to show here briefly the code that we were using for that. So in server.js, the main piece of code here is where we just use this Langflow proxy service, and I have kind of configured information about the flow. So that now node server becomes a proxy for Langflow. So the browser interacts with the node server, and the node server passes the request on to the Langflow server, gets that HTML and responds back to it. On the browser HTML side, this EJS template, partial, here's where we basically define our chatbot. We say, well, look, here's the profile that we're using, kind of the identifier for it, and where I'm going to put it, and off we go, we initialize. And that gets us the chatbot that we want to have. And I'm going to go over to here on my local host because it was, that container is working up. We were looking for robot with legs, right? And we'll see what we get back with this. As Dieter had shown, we had that hybrid search where we got the great result with where we specify both the vectorize and the lexical components. And this again, through the prompt, is going to have worked out the vectorize and the lexical components. And we're going to get back some of our examples here. Now, one of the tricks that you may realize here is that with the previous results, if I did robot with legs and legs, we get back a lot of results that don't have, right? If I shrink this down, really legs are what's important to me, right? We have all 7 of these, but then this is not a robot with legs. So the advantage of the chatbot is it's able to search for that with context. Actually, you say, no, actually, wheels, right? So we can, again, the chatbot now has this full context of this. Hey, look, here's what the user asked, and here's what I gave back as an answer. And so we're looking for robots, right, with wheels. So it's now given us some answers here with wheels. So the chatbot has then allowed me to not have to have the user go back and say, oh, I want robot with wheels. Any wheels, right? There we go. So here's some things with wheels. These guys have wheels in them, customized wheel robot, battle robots. Cool. So that's the basic idea here of what the chatbot's done for us. All right. So with that, Dieter, I'm going to throw back to you. Maybe. There we are.
Yeah, perfect. Let me share again. So, yeah, cool. So this was the content we wanted to walk you through today. Hope you find it interesting. And actually, as said before, we are super interested to understand if this was valuable for you. And if you have any feedback, also reach out via LinkedIn. That would be great. So we covered quite a lot, right? And we provided you with everything necessary for you to modernize legacy search capability in an application. And yeah, so with this, I think
we have a few questions to answer here, Dieter.
Exactly. But before that, maybe I would like to thank all the attendees for joining the session today and for spending time with us. And we covered the questions that we have in the chat in a second. So thanks all for tuning in and for your attention. Hope you found this useful. All of the code we walked through is available within the Kinetic Constructs GitHub repo. And please reach out if you have any questions. So, hey, with this, well, let's have a look at the questions that we have in the chat.
Yeah.
Yeah.
So I was looking at these as Dieter was coming along here. So first I saw here were from Matthew. Hello. And so your question here was, how do you reconcile the need for fast, low latency vector retrieval with transactional guarantees like serializability, especially when embedding updates and hybrids, semantic symbolic queries happen concurrently? Is Astra concurrency model inspired by optimistic concurrency control, MVCC, and how does it ensure isolation without introducing deadlocks or validation bottlenecks under high concurrency workloads? A question after my own heart as a database person. So Astra is under the covers based on open source Apache Cassandra, and it's based on currently Cassandra 4. And that has a high availability distributed model of compute, where it's, how will I put it? It's kind of, you can configure how you want to look for the compute, what's important to you. Do you want low latency, in which case you might just look for the current result, and it doesn't matter that I get the exact one, or you can use the common way would be quorum, where I have written 3 copies of the data, but my write only comes back once 2 of them are essentially committed to the different nodes that have the copies. So there's a concurrency model there. In terms of kind of ACID transactions, that's a Cassandra 5 capability that's not currently in, but for large numbers of applications, and particularly where we have vector stores kinds of applications, this is not so much of a problem in consideration. Concurrency, though, with writing into your vector store and reading from it at the same time, that's one of, in fact, the advantages of our technology over others. There is not like a batching of index updates. You write data into Astra or HCD, and it's available immediately for query. You don't have to kind of wait for things to happen, for index rebuilds to happen. It all happens automatically. So you really get true read-write concurrency. And then from a scalability perspective, I mean, Cassandra as a whole is built for scale. Astra is built for scale. HCD is built for scale. And when I say scale, I mean, you know, Netflix runs on Cassandra. Apple's technology runs on Cassandra. It's scale. It's a database that was built and designed for global scale, distributed computing in multiple regions if you want to have data in across multiple regions. So the underlying database is definitely built for scale. I don't think there's many vector workloads that are actually at this point kind of anywhere near what gives Cassandra sweat. So from a hybrid search, I don't know, Matthew, if that has answered your question or not.
I think, Phil, we can add on that question a bit, and it might also answer Avinash's question.
Yeah, great.
So you say evaluating vector database right now. So I would like to add here. So, hey, there is a Forrester Wave report about vector databases, and AstraDB actually is the hybrid leader. So when it comes to a hybrid vector database, so it is ahead of all the other vendors. And yeah, so the reason of all that is actually, so Phil already summarized many of the things, right? And it has the capabilities of what makes Cassandra strong. So it is super good when it comes to highly concurrency. It is super performant and it's super available. And the most important thing in the Gen AI world actually is accuracy. So it is accuracy. So many of these databases around, they have the vector capability, but actually the difference is how accurate is what is retrieved out of the database. And this is where AstraDB really shines.
Yep, you can tell who is the salesperson and who is the technical person.
I'm a technical person. I'm a developer. So.
You live in sales world. I less so. Okay. Another question here on line chain documentation says that the hold on here. Get the right question here. The underlying AstraDB typically supports hybrid search lexicable vector ANN to boost the results accuracy. This is provisioned and used automatically when available. So at the moment, the hybrid search is available in AWS, US East 2. And so if you're using Langflow in that region, you have hybrid search available to you. It's in preview mode, as Dieter kind of indicated earlier. It will be being rolled out to other regions. Exactly how that works is a little bit up for discussion. But if you've got questions about particular use cases that you want to build out, please do reach out to Dieter or myself, and we'll kind of follow up with you. It's not a problem with that. But if you're using it there and you're using the hybrid search as I had shown in the Langflow, that was the question there. Okay, and then there's some questions. I'm trying to juggle back and forth here with this platform. There's questions in chat. Okay, we've got a question here. evaluating vector databases. Can I use this method building independent product sourcing standalone chatbot? I'm not quite sure, James, what you mean by that. But absolutely, the first off, Langflow, it can be used, right? It's an open source thing. It can be used to build your own products. Astra DB is a document database, and it can do structured data as well. If you want to have a more formalized data model in terms of tables and columns, it supports both that and documents. And then the other resources there, particularly the Langflow Chatbot, that's available as an NPM module that I've built over the last week and a bit. Again, with all AI, I'm not a front-end guy, but it's kind of a work in progress. So if you've got questions, issues with that, or want to contribute back to make it better, happy to continue to be the maintainer of that little project. I don't know if that has answered your question, James, or not.
So I think, Phil, we covered all the questions so far. So is there any other question someone would like to ask? But also, please feel free to reach out to us after the session via LinkedIn. We would be glad to connect with you.
Yeah.
So it looks like there is no other question.
Oh, we just got one in. Have you evaluated any other vector DB for this use case? Well, for this use case, no. I mean, in terms of this particular kinetic constructs, etc. So we're building it with our own database technology. There are others out there. You're welcome to try to implement this on those other databases, but this is really a demonstrator kind of application that I've used. So no, I've not, but we do as DataStax, a large amount of evaluation against ourselves and other competitors when Dieter is talking about our ability to, I'll say, more precisely deliver high recall as opposed to accuracy, but that's the data scientist person in me. We it's one of those things that we pay very close attention to, and as you've got larger and larger data sets in particular, we want to work with you and make sure that we have some of the underlying parameters adjusted to you, or the auto adjusting stuff is being built there. So it's a large number of use cases are served very well by Astra DB and by HCD, our DataStax database technology.
Okay, so Phil, I believe we are close to the full hour.
Yeah.
So with this, hey, many thanks for spending time with us. Yeah, and we are looking forward to hear back from you via LinkedIn. Have a great day, and enjoy working and building things with Astra DB and Langflow.